Hello, my name is Severio Perugini, and today I'm going to be presenting our Journal of Functional Programming paper, Emerging Languages, an alternative approach to teaching programming languages. I'm in the Department of Computer Science at the University of Dayton. So while the learning outcomes of a course in programming languages are well established, the most effective approach to teach a languages course is not a settled matter. There are a myriad of approaches. The two predominant approaches are the principle/concepts-based approach and the interpreter-based approach. There's also a paradigm survey-based approach. There are hybrids of these. Each involve challenges. In this work, we challenge the idea that a course intended to convey the concepts of languages should therefore be structured according to those concepts. We sought to teach programming languages from a different perspective. The approach we developed involves using emerging languages as a conduit through which students incidentally bump into the concepts of languages, the implementation options available for them, and the compelling consequences of those options on programming, which are the student learning outcomes, the SLOs of a course on programming languages. Now, when we say emerging languages, what we mean here is languages that have adopted functional features to some extent or another in the last 20 years or so. So languages like Lua, Elixir, Go, Python, and so on. And despite the moniker for this approach, the goal here is not to teach students emerging languages. And thus the course must not involve, or perhaps I should say devolve, into an isolated rote investigation of a sequence of emerging languages. Rather, the goal here is to teach students the principles, concepts of languages as an intended, though unadvertised, side effect of covering these emerging languages under the guise of a survey course on a variety of hot new languages. The central thesis of this work is that this alternative approach results in a variety of course desiderata: scope for instructor customization, alignment with current trends in language evolution, practice, and research, and probably better aligned with industrial needs. What I'm going to discuss here is the rationale for, the course mechanics supporting, and the consequences of this approach. So the rationale for the emerging languages approach is based on some simple ideas. First, let's recognize that students think in terms of languages, not concepts. I call that the student language-centric perspective. Learning concepts of programming languages sounds dull and academic. Learning languages, especially new and emerging ones, and how those languages apply in domains in which students have passion, like game programming, Internet of Things, web frameworks, sounds like fun. So why not take advantage of the juxtaposition of these circumstances? If we tell students they're gonna learn Lua, Python, Ruby, that's something they can get excited about. Let's get students excited about what they're studying and then most effectively harness that motivating spirit to meet the learning outcomes of the course. Exploring the concepts, implementation options, and the implications of those options on programming. So step one, students think concepts, thinks languages, not concepts. Let's further recognize that students are motivated to learn emerging technologies that they perceive as relevant to the software industry, even if they're only ephemerally relevant. That's what I would call the student relevance-centric perspective. Most average students are typically not going to get excited about a required concepts of programming languages course, whose description indicates the use of Lisp as an implementation language, which the students perceive as not being used in industry, not building the resume, and not helping them get a job. Students, however, are motivated to learn new hot languages and novel emerging technologies. Students perceive emerging languages like Python and Ruby as less academic, more fun, and more practically applicable to real-world problems than languages like Lisp, which they perceive as archaic and arcane. I think the reason for this perception is that this perception is formed and influenced by the culture of the online ecosystem in which students explore, probe, experiences new languages and new technologies on their own. Things like blogs, YouTube videos, Stack Overflow, GitHub, and so on. So why can't we teach students first class and higher order functions and closures in Python rather than Lisp? I mean, ultimately, nobody cares if a student can program Lisp. Rather, they care if a student can think like a Lisp programmer in higher order abstractions, metaprogramming, and a variety of other languages. So let's harness that process of programming language acculturation, incubation, in which students participate, perhaps unconsciously. Given those circumstances, we think it's reasonable to use emerging languages as a method or conduit by which to distill concepts of languages to students. And then, of course, let's build a course framework around that idea, and let's use course mechanics that leverage how students learn languages on their own to teach them concepts. So that's what we did. We designed a course framework to support that approach or to operationalize that approach. And the model we came up with involves it's a module-based approach. It involves 3 modules. It's a module-based design, I should say. It involves 3 modules. Students were given a foundation and a vocabulary in language, a brief foundation of vocabulary and language concepts through sort of a functional programming tutorial in module 1, which formed the background from which they deconstructed the emerging languages presented in module 2, deconstruct those languages into the concepts, and then probe those concepts for subsequent comparison, synthesis, use, application of those concepts in final culminating projects in module 3. So module 1, brief introduction, identification of language concepts. Module 2, deconstructing the emerging languages presented to probe those concepts. In module 3, reconstruct, synthesize, apply those concepts in projects. Now, that third module also helps connect those languages back to the concepts in module 1. Module 2 is really the heart and soul of the course. The most number of weeks, 6 to 8 weeks. It's really the body of the course, the meat of the course. Now, I do want to mention in module 2 is really where the instructor has the opportunity to emulate as much as possible the process by which students learn languages on their own through those online fora I was discussing earlier. So this is the module where we did YouTube videos, we did language cheat sheets or quick reference sheets, we did online style blog web pages, we did language synopses, a lot of active learning going on. Students presented each language over the course of 2 consecutive 75-minute periods, really trying to emulate the process by which students learn languages. This also provided graded preparation for their final, the same sort of mechanics that were used in their final culminating project. We've offered this course 3 offerings using this approach. And these are some of the languages that we used across some of those offerings. This is a subset of them. And this is the student artifacts and final projects and cheat sheets and YouTube videos are all posted in this GitHub site, which I probably will be able to demonstrate or at least illustrate later. Module 3 is really the module where students were given the opportunity to demonstrate a mastery of those concepts distilled during the emerging languages presentations. And really demonstrate how they can use their intuition to independently discern how and when and creatively harness an integration of a subset of those concepts that they absorbed in that module to craft a solution to a practical computing problem. in Module 3. The project involved a software system, formal term paper using the ACM conference style and LaTeX, and an in-class presentation to classmates. Now, without a formal research experiment, it's challenging to ascertain the merit of this approach in helping students understand the core language concepts. We can, however, offer some anecdotal and formal evidence. This table I'm showing you here presents the observed frequency of the use of language concepts, in the source code of the final projects. Now, again, while the observation of an application and integration and a use of these concepts in the final projects cannot on its own serve as formal evidence that they understood the concepts, it does provide some anecdotal evidence, particularly because many of these projects were of high quality and some were even published. Okay, wrapping up here, what can you expect from this approach? What are the consequences? It's customizable. The instructor is picking different languages every semester. The mechanics are somewhat customizable, although to a lesser extent, because we're trying to use mechanics, which one of the main ideas here is using mechanics which dovetail nicely with how students learn languages on their own. It gets students away from their Java-centric worldview. We're covering a wide spectrum of languages in a relatively short period of time, which really radically shatters students' Java-centric worldview, promoting the idea that students should use languages for the particular problem domain. We're covering things like new concurrency models, CSP, Actor, Julia, scientific computing, Lua, game programming, MapReduce, so on. Promotes academic integrity. You're rotating the languages out every semester. Doesn't require a big, inordinate, and excessive work on the instructor's part because the students are producing the artifacts. Doesn't compromise learning outcomes. The outcomes are the same, the mechanism's different. Aligns well with industrial needs, promotes professional preparation and academic preparation. Of course, there are challenges. Scaling the approach is certainly a challenge, especially in sections with large number of students, 50 to 100 students. There's an entire section in the paper dedicated to some sort of rough calculations on how you might adapt the approach to large sections. There are some other challenges as well, which are mentioned in the paper. Concluding, the idea presented here, the approach presented here is based on the idea that we should teach programming languages to students in a mode that meshes well and leverages both how students think languages, not concepts. They put languages before concepts, and how they learn languages and new technologies on their own, online fora, YouTube videos, Stack Overflow, and things like that. I hope, my goal with this presentation and this paper is that get the discussion going, challenge the idea how we teach programming languages. I hope it encouraged people to think, folks to think differently and to bring this back to their institutions. I encourage you to explore our web pages, especially our GitHub site, which involves all the language synopses, YouTube videos, presentations, and then some of the projects are posted as well. At this point, I'd like to thank you for your attention, and I certainly welcome you to contact me with questions and comments. Thank you.